Hello and welcome to Chapter 10. Section 3 today is all about acceleration. So we're going through the basics. This is a quick slideshow. A lot of the work we're going to see is in the math that we get to do in class tomorrow. So we're going to start with some basic vocabulary. Acceleration is the rate velocity changes with time. So this is not speed. Speed is the change in distance over time, the change in an object's position over time. But velocity is the speed. So we're looking at the speed, how the speed changes over time. So for example, if you're in a car and you're getting on the freeway, and your speed getting on the freeway on the on-ramp is 30 miles an hour, but on the freeway at 60 miles an hour, you have accelerated. So we need to be able to measure that with math. So, and you have to remember velocity is speed and direction. So you can accelerate by speeding up. In science, you can accelerate by slowing down, and that would be a negative acceleration. You can also accelerate by changing direction. So while we, mere mortals, use acceleration just to mean the first one, scientists use it for all three. So we have to understand how all of those three work. Okay? We're going to look at how to calculate acceleration. We're going to compare the initial starting velocity with the final velocity, and we're going to find the change there, which is just a subtraction problem, and then we're going to divide it by time. And the formula looks like this: final velocity minus initial velocity divided by time. So it's a matter of picking the speed that you're starting with and the speed that you're ending with. And the units are meters per second squared. This is meters per second per second. Meters per second is speed. And you know that, we've done that. But I want to know the meters per second every second. So we're looking at the overall change in speed, change in meters per second. So that's a meters per second every second. That's where the meters per second or meters per second squared comes in. Okay? Now, the math isn't hard here. What's hard is remembering the units. So if you can just realize what you're doing and which formula goes with which set of units, you should be okay. All right? Something else I want you to realize is if you get a positive answer, your acceleration is speeding up. If you get a negative answer, that means you're slowing down. Now, let's think about this a minute. If you've got a car that you are getting on the freeway, your initial velocity on the on-ramp is about 30 miles an hour, and your velocity on the freeway is about 60 miles an hour. And so you're going to take final velocity, 60, minus initial velocity, 30, and that's going to give you a 30 divided by however much time it took you to do that. As opposed to, you're on the freeway, you get on the off-ramp, so your initial velocity is 60, your final velocity is 30. Now you're doing final 30 minus initial 60, and you end up with your answer then is negative 30 divided by time. So the answer shows you, if you can keep track of your negative numbers, your answer shows you whether or not you're speeding up or slowing down. Okay? Now, velocity time graph versus a distance time graph. These two graphs are telling kind of the same story, but they're telling it from different perspectives, and I need you to understand the two kinds of perspectives, because when we put our information into graphs, we have to understand what it is we want to tell our audience so that we understand how to present it. What number needs to go on the left-hand side? Because notice on the bottom of these, both of these have time on the bottom. Time always goes from left to right, so that as you look at this, at this line, you're going from the beginning to the middle to the end. Okay? I'm going to start with the one that you've already seen, the distance time graph on the right. Here we have time on the bottom, and we have distance on the side. That means that as we're marching through time, the distance from the spot where we started is always increasing, which means we're going in one direction. And we keep getting farther and farther away. But what it's telling you, because it's measuring velocity, is that you're starting at 0. And so you never just start immediately going fast. You actually have to speed up. And it shows you with that nice little curve that it's speeding up. That's velocity increase. That's the red line. Then the blue line is a flat line. That means you're staying at that 60 miles an hour on the freeway. And then the green section is you getting on the off-ramp and you're starting to slow down. So you can see that curve of gently slowing down until you finally hit 60 meters from your starting point in 30 seconds. So it's a really small freeway, but you understand what I'm saying, right? Now, the velocity time graph, notice that the left side of this graph is velocity, it's not distance. So what this is measuring during the 30 seconds that are going by, it's measuring speed. How fast are you going? So in that first 10 seconds, how fast are you going? Well, you're going from 0 to 3.0 meters per second. So you're going really fast in that first 10 seconds, and that's what the red line shows you. The blue line shows 0 acceleration. It means you're not going faster. You've hit 3.0 meters per second and you're still going 3.0 meters per second. So that shows that you're going equally fast. You're not speeding up, you're not slowing down. That's what the horizontal line means. You've stopped increasing or decreasing whatever's on the left, your velocity, your speed. And then once you hit the beginning of the green line, that's where the car starts to slow down. And so because this graph is measuring velocity, it's measuring speed, the line going down means you're actually slowing down. So I can use the same car on the on-ramp, car on the freeway, car on the off-ramp example for both of these graphs, but the information that they're giving you is different. Okay? Now we're going to play with these a little bit in class, so I need you to kind of understand the difference and realize what it is we're asking when you graph points. Okay? But, ta-da! We're done with chapter 10 already. Introductory chapters always go quick, so I will see you next week for chapter 11. Thank you very much.